Right, let's do example number 4. Okay, so let's firstly draw the free body diagram. So free body diagram, we have the ball here, and then let's draw the forces experienced by this ball. Let me find the color. Okay, so we have weight is what numbers are weight, and then it has tension. What else? That's basically it. And then the angle is theta here, theta. This is the angle theta. Okay, so this is G, this is the tension. Okay, so that is the free body diagram. Remember, we do free body diagram, and then if there is an acceleration, we will be following the direction of acceleration to be positive lah. So forces yang acceleration dia follow the direction of the acceleration, dia jadi positive. And remember, the direction for the centripetal acceleration is always pointing towards the center, which is like this. So if we draw it here, acceleration is pointing to the left lah. Okay, now let's continue. We've did the sketching of free body diagram. Now we have to determine the tension in the string, the speed and the period of the bob, finally the radial acceleration of the bob. Okay, so let's try to split this into x and y component. So firstly, let's look at the y component. So total force at y component should be equal to 0, as it is not moving up and down. It is only moving horizontally, which is at the x component. Okay, so force at y equal to 0, we only have t cos theta equal to 0. Good job. Lupa. Minus mg equal to 0. So basically t cos theta is equal to mg. Okay, so now t is mg over cos theta. So the tension is equal to 788 Newton. I won't do any substitution, okay? Just to keep our videos short. Okay, so we found the tension in the string. Now we have to find the speed and the period. Okay, so the speed can be calculated using the formula net force F net equal to the centripetal force. Okay, so now the net force is the x component or total force at x is equal to the centripetal acceleration, which is equal to mac. Okay, so total force at x is equal to mv square over r. Okay, yang v square over r ni dapat daripada centripetal acceleration. Okay, just substitute v square over r di situ. So now let's look at the x component. We have t sin theta. T sin theta is positive sebab dia follow the direction of the centripetal acceleration. Okay. Lepas tu equal lah dengan mv square over r. However, we do not have the radius of the circular path, which is this one. We do not have this r, but we can find it by using trigonometry, which is sin theta equal to r over l. Okay, sin theta is equal to r over l is just this one. So this is theta. Sine is opposite, and then hypotenuse. So this is opposite, this is hypotenuse, which is equal to r over the length of the string. Okay, boleh faham? So you then get the angle to be equal to the angle pula. The radius to be equal to L sine theta. Okay? Okay, lepas tu rearrange this, you should get TL sine square theta over M. Okay? So after rearranging and then substitute the R with this, you should get this lah. So if you plug in the values, you'll then get the velocity to be equal to 0.865 meter per second. Okay? Right, lepas tu kita perlu cari the period. Okay, so we know that period can be calculated using the tangential velocity, which is equal to R omega, where R omega is equal to 2 pi over T. So T is, susun balik ka ni? Yeah, kamu susun sendirilah. So 2 pi over T, nanti kamu rearrange, kamu akan dapat T equal to, susun je lah, 2 pi over V. Okay, so the period is then 6.33 seconds. Okay? Okay. Last one. The radial acceleration of the bulb. Now, radial acceleration pula, it is equal to V square over R. And then V ada sudah, R is just L sine theta. So you should be getting the centripetal or the radial acceleration to be equal to 0.859 meter per second square, which is going towards the center of the circle. Alright, so that is example number 4.